Okay everyone, this is video number 14. We're going to do some factoring of polynomials. So if you look at these two polynomial expressions, guys, notice the first one has only two terms, whereas the one near the bottom of the screen has three terms. So, and the bottom one is more what we're familiar with when it comes to standard form, right? The top one is standard form, we're just missing the constant at the end. But the whole point is, whenever I have two terms, guys, about 90+% of the time, I'm going to do a GCF. So what am I going to do? I'm going to look at each term and see what they have in common. Notice how they both have an x in common there. Because x squared is x times x after all, right? So this one should be a fairly simple one to factor. If I know my GCF, my greatest common factor is x, all I need is an x times x to give me x squared, and a minus 4 times the x to give me a minus 4x. And so this is the factored form of my original expression. Now the bottom polynomial expression is not going to be GCF. Of course, we should always check. Notice 7, 68, and 20 are not multiples or have a common factor, correct? So this one I factor what I call using parentheses or FOIL backwards. I know 7x times x, for example, is 7x squared, and there's really no other way to do that, right? 7 times 1 is 7 after all. Now what about the 20? Well, normally I think of 4 times 5, but notice the big large number term in the middle, guys. Because of that, that's why I'm going to do 2 times 10 instead. Because 2 times 10, of course, is a 20. But I notice right here, I know 7 times 10 is 70. See how I already got close to 68? 2 with x, of course, times together is 2x. Can I make a minus 68x? Of course I can. All I need to do is a positive 2 minus 70, right? So I'm just going to do a plus 2 to get my plus 2x. A minus 10 here times 7x is negative 70x. 2 times negative 10 as well is that negative 20. Always got to make sure everything matches up, but everything does match up perfectly. So my resulting answer, of course, is just 7x plus 2 times x minus 10. That is the factored form of the original polynomial there. Pause the video if you need to. Okay, so let's do it one more time. Now notice this next expression has 3 terms in it. So am I going to do a GCF, especially when there's no number in front? Let me repeat that. Notice there's no number in front to find a real common factor except for 1. So what do we do when we have 3 terms? Over 90% of the time, guys, we're going to go right to parentheses. I know that m times m is m squared. I notice 50 is normally 10 times 5. Can I get a minus 15? Well, I know 10m and 5m add up to 15. Now I need a negative, so I'm just going to make sure they're both negative, right? Because a negative 10 and negative 5 is negative 15m. Negative 10 times negative 5 as well is positive 50. Finally, we're going to do the last expression on the bottom here, guys. Notice it does have a coefficient of 3 in front, but 3 is not a factor of either one of those numbers. So we do not have to worry about GCF, okay? So we're just going to go right straight to parentheses. I'm going to take 3n times n to give me 3n squared. Now the 70 normally is 10 times 7. And I know that if I put the 10 here, see how the 10 times 3 is going to give me a 30. And that's way too large for that 11 right there. So instead of 10 there, I'm going to put the 10 here and the 7 over there. And you see, by doing that, let's see how my loops work here. I know 10 times n is 10n. I know 7 times 3 is 21n. So notice I can now get 11n, because if I do a positive 21 minus 10, I do get that 11n. So therefore I'm going to put a minus there, so I get my minus 10 in, and I'm going to put a plus there to get my plus 21 in. And so guys, that is how you factor.